You've awakened to how your brain works. You've learned how to prime it for learning. Now we need to go deeper. We need to look under the hood and understand the actual machinery. Because learning isn't magic. It's mechanics. There's an engine running beneath the surface, converting experience into skill, and most people never see it. They practice blindly, hoping something will click, never understanding the principles that govern how their brain actually builds capability. But once you see the engine, once you understand the hidden machinery, everything changes. You stop guessing. You start engineering. Let's reveal how skill is actually constructed inside your nervous system. Neuroplasticity follows attention and reward. We've touched on this before, but it's worth drilling deeper because this is the core algorithm. Your brain doesn't rewire randomly. It rewires according to a simple rule. What you pay attention to, combined with whether it feels rewarding, determines what gets strengthened. Attention marks the circuit. It says, this is happening right now. Reward releases dopamine, which says, this matters, remember this. When both signals occur together, the synapses involved get tagged for strengthening. During sleep and rest, those tagged synapses are consolidated, made more robust, integrated into your permanent neural architecture. No attention, no tag, no reward, no dopamine, no consolidation. You can do something 1,000 times, but if you're not paying attention and there's no sense of reward or progress, your brain won't bother strengthening those circuits. This is why mindless repetition doesn't work. This is why you need both focus and feedback. The practical implication is clear. Every practice session needs two ingredients. You need to be present, fully attentive to what you're doing. And you need some signal that tells your brain this is working, this is progress, this is good. That signal can be external, like hitting a target, or internal, like the satisfaction of getting something right. But it has to be there. Because attention and reward together are the fuel that drives plasticity. Prediction error drives updating. Your brain is constantly making predictions. When you reach for a cup, your brain predicts where your hand will land. When you speak a sentence, your brain predicts how it will sound. And here's the key. Your brain only updates its models when its predictions are wrong. This is called prediction error. The gap between what your brain expected and what actually happened. When there's no error, when everything goes as predicted, your brain assumes the current model is correct and doesn't change anything. But when there is an error, when something unexpected occurs, your brain pays attention and adjusts. This is why mistakes are so valuable. Every mistake is a prediction error. Every time you swing a tennis racket and miss, your brain detects the mismatch between the swing it predicted and the swing that happened. And that mismatch is the signal to update, to recalibrate, to learn. People who avoid mistakes, who only practice things they can already do well, deprive their brain of prediction errors. They deprive themselves of the very thing that drives learning. Meanwhile, people who embrace errors, who deliberately push into territory where they fail frequently, generate constant prediction errors. Their brains are constantly updating, constantly improving. So if you want to learn fast, stop seeking perfection. Start seeking errors, because errors aren't failures. Errors are the raw material your brain uses to build better predictions, and better predictions are what skill actually is. Fast feedback accelerates rewiring. Imagine practicing a golf swing and waiting a week to find out whether your form was correct. Absurd, right? And yet, that's essentially what happens in many learning contexts. You do something, and the feedback comes so late that your brain can't connect it to the action that caused it. Your brain needs feedback fast, ideally within seconds, because the neurons that fired during the action are still active, still available to be modified. If feedback arrives while those neurons are still in their plastic state, the connection between action and outcome gets encoded powerfully. But if feedback arrives hours or days later, the neural trace has faded. The learning opportunity is lost. This is why video games are so good at teaching complex skills. The feedback loop is instant. You press a button, something happens on screen immediately. Your brain makes the connection effortlessly. Compare that to traditional education, where you take a test and get the results back 2 weeks later. By then, your brain has moved on. The circuits that were active during the test are cold. If you want to accelerate your learning, you need to engineer fast feedback. Use tools that give you immediate results. Practice with a coach or partner who can correct you in real time. Record yourself and watch it back immediately. Set up your environment so you know right away whether you're doing it right or wrong. Because the faster the feedback, the faster the rewiring. It's not just helpful, it's biologically necessary. Error awareness is biologically required. Here's something most people don't realize. Making a mistake isn't enough. You have to know you made a mistake. You have to be aware of the error. Because if you practice something incorrectly and don't realize it, your brain treats it as correct. It reinforces the wrong pattern. This is why practicing without awareness is so dangerous. You can groove bad habits deeply into your nervous system without even knowing it. And once those patterns are encoded, they're hard to undo. You have to unlearn the wrong way before you can learn the right way. Error awareness activates specific circuits in your brain, particularly in the anterior cingulate cortex. This region detects conflicts, mismatches, things that aren't quite right. When it fires, it sends signals that say, stop, adjust, something needs to change. And that signal is what triggers learning. So how do you build error awareness? You pay attention. You focus on the quality of your execution, not just the outcome. You develop sensitivity to what correct feels like versus what incorrect feels like. You ask for feedback. You record yourself. You compare your performance to a standard. You don't just practice. You practice with awareness. Because unconscious repetition builds nothing. Conscious repetition, where you notice and register your errors, builds everything. Mistake correction beats mistake avoidance. There are two ways to approach learning. You can try to avoid making mistakes, staying in the safe zone where you already know what you're doing. Or you can actively seek out mistakes, push into the uncomfortable zone, and focus on correcting them. The first approach feels safer. It protects your ego. You don't fail as much. But it also means you don't learn as much. Because as we've established, your brain learns from prediction errors. No errors, no learning. The second approach feels riskier. You fail more often. You look worse in the moment. But you learn faster. Because every mistake you make and then correct is a completed learning loop. Error detected, adjustment made, new pattern encoded. Research on skill acquisition consistently shows that learners who spend more time making and correcting mistakes outperform learners who try to perform perfectly from the start. The mistake makers struggle early, but they accelerate past everyone else because they're feeding their brain the signal it needs to update. So shift your relationship with mistakes. Stop seeing them as things to avoid. Start seeing them as opportunities to correct. The faster you can cycle through make mistake, notice mistake, correct mistake, the faster you'll build skill. Mistake correction is the engine. Mistake avoidance is the brake. The brain learns subsystems before systems. When you look at an expert performing a complex skill, it looks seamless, integrated, like one fluid motion. But that's not how the brain builds it. The brain builds complex skills by learning small subsystems first, then gradually linking them together. Think about learning to drive. You don't learn to drive all at once. First, you learn to steer. Then you learn to use the pedals. Then you learn to check mirrors. Then you learn to merge into traffic. Each one is a subsystem, and your brain has to automate each subsystem individually before it can integrate them into the larger system of driving. This is why breaking skills down into components is so effective. You're working with your brain's natural architecture. You're not asking it to learn everything at once. You're letting it build the subsystems first, one by one, until each one becomes automatic. And then, almost effortlessly, your brain starts combining them. If you try to learn the whole system at once, you overwhelm your working memory. You can't pay attention to everything simultaneously. But if you isolate one subsystem, master it, then move to the next, you're building a stable foundation. Each piece becomes automatic, freeing up your attention for the next piece. And eventually, all the pieces snap together into fluid, expert performance. So when you approach a new skill, ask yourself, what are the subsystems? What are the individual components I can practice separately? Master the parts. Trust that your brain will assemble the whole. Chunking reduces working memory load. Your working memory is limited. You can only hold about 4 to 7 pieces of information in your conscious awareness at once. This is a hard biological constraint. You can't hack it. You can't expand it through sheer effort. But here's what you can do. You can chunk. Chunking is the process of grouping individual pieces of information into larger, meaningful units. Once chunked, what used to be 7 separate items becomes one item, and suddenly you have room in working memory for more. Think about how you remember a phone number. You don't remember 10 individual digits. You chunk them into groups: area code, prefix, line number, 3 chunks instead of 10 digits. Your working memory can handle that. Experts chunk constantly. A chess master doesn't see individual pieces on the board. They see patterns, configurations, threats, opportunities. What looks like 32 pieces to a novice looks like 3 or 4 meaningful chunks to the master. This is what frees up their mental bandwidth to think strategically, while the novice is still trying to keep track of where everything is. As you practice a skill, your brain automatically starts chunking. Small actions that used to require conscious attention get bundled together into automatic routines, and as those chunks form, you feel the cognitive load decrease. What used to feel overwhelming starts to feel manageable. That's not because the task got easier. It's because your brain got more efficient at representing it. Compression is mastery. Let's take chunking one step further. Mastery isn't about knowing more. Mastery is about compressing what you know into simpler, more elegant representations. It's about taking 1,000 details and distilling them into a few core principles. A beginner needs a checklist. Step 1, Step 2, Step 3, don't forget this, remember that. An expert just does it, because all those steps, all those details have been compressed into an intuitive understanding. The expert doesn't think through the mechanics anymore. They've internalized the structure so deeply that it's become automatic, almost invisible. This is what your brain is trying to do as you learn. It's trying to find the pattern beneath the noise. It's trying to compress the information into the smallest, most efficient form. And when it succeeds, that's when you experience the feeling of mastery. Suddenly, something that used to require intense focus becomes effortless. You just know what to do. You can accelerate this process by actively seeking simplification. After practicing, ask yourself, what's the core principle here? What's the one thing that matters most? Can I explain this more simply? Your brain will do some of this automatically, but if you consciously push toward compression, toward elegant simplicity, you'll reach mastery faster. Because compression is the endpoint. It's what mastery actually looks like in your neural architecture. Overlearning stabilizes performance under stress. You know a skill well enough to do it under perfect conditions. Quiet room, no pressure, plenty of time, but then you get into a real-world situation. There's noise, there's stress, there's time pressure, and suddenly the skill falls apart. Why? Because stress impairs your prefrontal cortex, the part of your brain responsible for conscious control and working memory. Under stress, you lose access to deliberate, step-by-step thinking. If your skill depends on that kind of thinking, it will collapse when stress hits. But if you've overlearned the skill, if you've practiced it so many times that it's become fully automatic, then it doesn't require prefrontal support anymore. It runs on autopilot, driven by deeper brain structures that aren't affected by stress. And that means your performance stays stable even when everything else is falling apart. This is why elite performers drill the basics relentlessly. They're not practicing to learn. They're practicing to overlearn, to make the skill so deeply automatic that no amount of pressure can disrupt it. If you want your skills to be reliable, practice beyond the point of competence. Keep going until it's boring, until you can do it in your sleep. That's not wasted effort. That's insurance. Because when the pressure comes, and it will, the only thing that will save you is what you've overlearned. Abstraction comes from context variation. When you practice a skill in only one context, you don't really learn the skill. You learn that skill in that context. Your brain encodes all the surface details, the specifics of the environment, the particular conditions. And if any of those details change, your performance degrades. But when you practice the same skill in many different contexts, your brain is forced to figure out what stays the same across all the variations. It has to extract the abstract principle, the core structure that's independent of context. And once your brain identifies that abstraction, you've achieved true understanding. You can now apply the skill anywhere. This is why varied practice is so powerful. If you want to learn to shoot a basketball, don't just practice from one spot on the court. Practice from every spot. Different angles, different distances, different lighting. Force your brain to separate the essential mechanics of shooting from the incidental details of where you're standing. The same applies to any skill. If you're learning a language, practice in different settings with different people. If you're learning to code, solve different types of problems with different constraints. The variation feels harder in the short term, but it produces deeper, more flexible learning in the long term. Because abstraction, the ability to transfer a skill across contexts, only emerges from context variation. There's no shortcut. Now you see the engine. You understand the hidden machinery that converts practice into skill. Attention and reward, prediction error, fast feedback, error awareness, mistake correction, subsystems, chunking, compression, overlearning, abstraction. These aren't random tips. These are the principles your brain follows whether you know it or not. And now that you know them, you can work with them. You can design your practice to align with how your nervous system actually builds skill. You're no longer practicing in the dark. You're engineering mastery, and that changes everything.